Okay, so this is the wrapping up the Iron Man gauntlet to the last gauntlet I'm going to do. Okay, now what I did here was I used aluminum foil, stacks of aluminum foil, and I folded out the sheets, laid them flat, cut a hole into it, cut another hole into it so I could fit my thumb. I overlaid it on my hand and cut a hole into the central, cut a hole and overhole into the side so I could put my hand in it. Aluminum foil. Then what I did was use the adhesive spray, and I sprayed it with adhesive spray, and I added the silicon. Oops, sorry. I added the silicon powder. This is a silicon carbide. Then what I did was I added the wax sheet paper. After I added the wax sheet paper, I then placed onto the wax sheet paper coils. So I added 1 coil, 2 coil, 3 coil, 4 coil, 5 coil, 6 coil, 7 coil. So there's 7 coils in here. And then I added the aluminum oxide. This is aluminum oxide polish. And I added the powder right here along with the silicon carbide. And this is silicon carbide. You see that right there? Okay. Then I've added this wax sheet paper again. And I'm able to deformate it and fold it on my hand. I will be using a hardener to harden it. I will be adding more coils on top of this, on top of the wax sheet paper. I shall be coating it with a waterproofer. So the waterproofer is going to be next. I'm going to let it dry. And then in the morning, I'm going to wrap it. I'm going to add more coils. And each time that I add coils, I'm going to add a stack of aluminum. So I added another stack of aluminum along with it. Aluminum foil. And we keep stacking it with coils and with aluminum and with silicon carbide and aluminum oxide. And keep stacking it. I'm going to leave this open clearance because I'm going to place a reservoir here. And that reservoir is going to be with copper BBs. It's going to be rotating around it, gaining electrical energy. I'm going to use a refrigerant cooler so I can cool the copper BBs. It's going to be mixed with aluminum powder. I think aluminum carbide, I guess. Aluminum mesh. And this carbide is about, I believe it's supposed to be somewhere near, I don't know, I think it's the 60. I think it's 80, it might be 80 Gs. It might be 80 Gs or more. It could be 600 Gs. I think it's 600 Gs. Anyway, when I add the coil, I use the hammer and some resin. I use some resin to mount it and a hammer to flatten the coils like a pancake. So there, it looks like the structure, but the coils around here we have the indentations of the gauntlet, and around here, embedded within the system. And I'm going to continue that into the indentations, or the two-dimensional, is localized on the side, around the base of the arc, whereas the emitter comes from. And my name is Ray Morton, and I'll be back. Wish me luck in my design. Oh, and I wanted to add. Now, some say, well, how does the motor work and how is it able to lift? Is you sure that able to lift a human being? Well, I don't know. Speculations suggest that. Speculations is like, okay, to use for example, this is a motor, right? This is an armature to a motor. And it's actually like a stator. It communicates with the outrunner. It's actually an outrunner. It uses a permanent magnet outrunner that rotates around these coil terminals, horns. Now the torque and the energy, even like a regular motor, like a brush motor, which may have DC phased and brush along the panels, having freedom in space to rotate, to move, as of an armature, that is not pushed or torqued by gears. If the electromagnetic field strikes against it within, let's say, a millimeter or 2 millimeters, or a millimeter apart from the surfaces, transmits the energy and causes it to rotate at high speeds or torque. Torque can be anywhere from horsepower or more than horsepower. If you as a human being are you able to stop a drill, a regular household drill, that may be powered by an AC current, like this drill, if you're able to stop the drill armature from rotating, see, this is connected to gears, so it gives it more of a torque. But as of the motor inside this, it has freedom. It's in a space of electrostatic when it is powered it, and it is DC phased to where it's touching to a metallic bond, causing it to turn, to rotate. The energy of self-repulsive is similar to the same force and torque. So if it's hard enough to stop the rotation, what about a linear motion for self-sufficient backwards, pushing backwards? So the electrical winding energy winds that way, towards the opposite way, towards the palm of the hand, push the palm of the hand back. As one who adjusts their hand in a vertical position, if one is going to flight, will push their hand up in the air. So if the same energy is about a horsepower or two, and is hard to resist, or restrain from its torque, then how much more would a linear motion do for self-propulsion? and against the Earth's gravity or inertial mass. How much more as of the human weight? So if I wrap these coils greater than this motor, which is a wheelchair motor, in number of turns, where it's repulsed by a permanent magnet, it's like a wheelchair motor. If I wrap the turns or attach the turns more than that, as of 2 times more, show this power more than that without the gearbox? I think so. I know so. So moving away more greater than the strength of the gearbox. And as of the torque is of rotation, but it's a force in a linear motion, straight that way, or this way, or this way. However, because I got the coils facing upward, the repulsor force, when the winding energy, depending on the phase in wire, the phase in will move downward, moving the aluminum away from the magnetic field, hardening it through stacks and making stacks to build up the gorge. Because remember that the coils, copper coils, must be equal to the mass of that which is repulsing. This aluminum reacts as coil turns, but in a rectangle form, in a large, broad, wide vector field, thus giving the same repulsive energy. Two comets of the same will repel one another. The opposites will attract. Now the magnetism comes from the carbide, which is like aluminum, which is like an iron mesh, and that is connected to you, thus adding the thermoelectric effect of refrigeration, lowering temperatures, and using also the a semiconductor like aluminum oxide. This, I think, it will probably work. So you tell me more about it and your opinions concerning if this device you think would probably work, or do you think it would lift a human being as a more than 500 pounds? I mean, a human being at 200 pounds. So I only need is about 1100 newtons force to lift me into the air. So we'll see next time, and I'm gonna keep building this, and you let me know what you think. Goodbye.